So hello again, this is Max, and today we are going to discuss how to build a simple sniffer using Python language and how to parse the IP header. First of all, what's a sniffer? So it's a program which sniffs the network and actually catches all the packets which go through this network. Using Python, this is quite simple. Well, first of all, we should create a special socket named raw socket. We should connect it to the network and then enable a special option which is available only in admin mode at Windows to catch all the packets. Then we will catch packets and we'll parse the IP header and see what we got. So first of all, we need the host of this machine, which is obtained by the combination of these two functions. Get host name will return the string, which is the name with the name of this machine, which is passed to the function get host by name, which will transform this string and will return the actual address. This host is then used with the function bind. Here we bind to this host and to 0, so we bind to our network address. But before binding, we actually should create the socket. And this is a special one because looking at these options, we see that this is a raw socket, so it deals with raw data. It is from internet address family, so basically it will deal with the Internet Protocol version 4 because here we specify the protocol. Next, we specify some socket options like set sock opt. Well, using this function, we specify it on the socket level, so we wanna reuse this address. Basically, if we're gonna launch this program many times, the address will be in time wait state, so we will reuse this address. After binding the host, we include some IP headers. Basically, we add some more options. Well, I read that it is necessary when we are using raw sockets to include the IP header included. So basically, this option specifies that well, this option we will use at the IP protocol. It's specified to include to all packets the IP header, and we state it to be true, so we enable this option. Then the magic of receiving all the packets, so this function call, basically we activate this receive all and we turn it on, and then this program is going to receive all the packets from the network. We enter an infinite loop where we use the rec from, and here we specify the buffer necessary for the packet. Yeah, this is a magic number, but where do we get this number? Where basically in the IP header we have a field named the total length, which specify the maximal length of the, well, not they specify the total length of the packet, but based on that data that field is 16-bit long, we can state that the maximal size of a packet is 2 at power 16, which is actually this number. So that's why I specified this number. We get the data and address, then we print that we got an IP packet with the size, corresponding size, and then we print the raw data, but after that we parse this packet. Basically we will not interpret the TCP or UDP, but we will parse only the IP header. I included here also the time sleep, so I can read what I caught. But let's analyze the parsing. Before actually parsing the IP packet, we should know what this IP packet contains. And an IP packet is formed by the header and the payload. And our task is to parse the header of an IP packet. So I use this scheme which represents how an IP packet looks like. So there are several rows of 32 bytes length every one, which is divided in some section or fields which contain a specified length and contain some special information. So basically I retrieve the corresponding bytes or bits and analyze them and print all the information from this header. And looking at this diagram, we of course see that the first field is the version, and it is composed of 4 bits. So basically we need to retrieve the first byte of the code packet, and from that byte we should catch the first 4 bits and then read the version according to the protocol. So let's see how I implemented this. Basically I transmit the first byte to the function which is save version, and version has the first byte. Then using bitwise operation of shifting I obtain the first 4 bits, and then according to the protocol I check what's the number there, and correspondingly I could have IP version 4, IP version 6 or other things. I also check if there is another number, for example if something happened wrong or maybe I didn't specify something right, I return the unknown. So for example the version is unknown. Next in the list of fields come the header length, which basically is 4-bit long. So the same byte is sent again to the next function which I named say header length, and this time we need to retrieve the last 4 bits, actually the least significant bits. So I use an AND bitwise and bitwise AND with this binary number. So the first 4 bits are zeros and the last 4 bits are ones, so I will have only the last 4 bits. That's here an interesting fact, because the actual header length is indicated as the number of 32 bits of words. Well, I said something wrong. So the header length specifies here, you see, the length of the IP packet header and 32-bit words. So basically what I wanted to say here, that if that number which is in length is multiplied by 4, and we will obtain the number of bytes. Why by 4? Because 32 bits is 4 bytes. And here also I find that the minimal value for a valid header is 5. So I check if this header is valid or invalid. Okay, let's go further. Here we have another field which is already 1 byte long, and I send this byte, oh here it is, which specifies the type of the service used. This type of the service, so I was talking about the type of the service, and here we need to retrieve the code point which represent the first 6 bits, and here we see that here is a table of the values which the code point can take, and here how I check this. Well, actually the simplest way is just to write an if-else construction to check for all these values, but basically we have here a rule, because for example for the first 8 values which start with CS and the number, the last 3 bits, the least significant 3 bits, are not changed, so are always 0, and only these values change from 3 zeros till 3 ones, so 8 values. And a similar approach we see here, another 16 values. So basically the most significant bit and the least significant bit are zeros, so they are not changed, and we check only these values. So that's how I check the type of the service. Coming back to our general scheme, we have the field name total length, which is 16-bit long. I already talked about it. Basically it states how big is the packet, and I simply compute this length. The next field is the flags, which is 3 bits. Basically, we have 2 flags here, the one that states don't fragment, and another one which states that more fragments follow this fragment. So as you know, well, when the user sends a big chunk of data, it is divided into several packets, and if this packet is one of the fragments, so we should specify it somehow. And we have 4 options. Either both flags are 1, or 1 is 1, 1 is 0, 0, 1, or 0, 0. So that's how I check it. The next field is the protocol, which is built on this IP protocol. So imagine there is an UDP or TCP, but basically we have quite enough protocols. For example, here are stated about 150. But of course, well, I didn't check them all. I tried to include the most important or the most used, like TCP or UDP. So basically, I simply check it using if, else if. Again, I transmit the byte number 10, for example, here from the data which I sniffed. And this function sayAddress is used to retrieve the address of the destination and the sender, because if we look here, we have the field source IP address and destination IP address, which are 4 bytes long. So basically, this function transforms these 4 bytes in a string, which is an usual address. Yeah, an interesting thing, why the header length can't be less than 5 bits, less than 5 bytes, because if you see here, 5 multiplied by 32 will give us this part of the packet, which is always present. Like, these fields are always present. The options and padding and the payload are basically optional, because they can be they can not be present. So that's why if the header length is less than 5, it is not a valid header. Well, 5 multiplied by 32. And basically that's it. I do not parse the remaining data. I simply state it like a payload, and well, here is interesting fact that data is from 23rd byte till the end. Why 23rd byte? Well, the IP header was built or designed in such a way that even if it is optional, it is completed with the padding, so it forms a complete row. So I know that the next data is going right from here, from the start, from the 23rd byte. Okay, basically that's it. Let's see how this program works. I'll run it. Okay, so let's try to do something here. For example, let's refresh this program, this page. So an IP packet with the size 52 was captured. Okay, let's stop this program and read what we've got so far. So this is the raw data, this is the parse data. So it was the IP version 4, the header length is 20 bytes, the type of service is CS0, the total length is 52. I'm happy that this number coincides always with this. That means that it's something right. Okay, the ID, well, I didn't say, well, yeah, the identification, I didn't say about it, but it's something similar. The flags, the fragment offset, the TTL, the protocol, TCP here, the source and the destination, and here comes the data, the payload, well, and so on. Basically that's it. Thank you.